And so welcome everybody to our second week of big data. Today let's see, I'll just start by sharing my screen so that we can, you can see what I'm saying as I'm saying it, and maybe that's easier to follow along with. And as I'm doing this, I might pause occasionally as I'm just making sure that everybody's getting admitted to the class here. And always, it's good to, I think, start off with a reminder that especially since we're online, it's difficult for me to see everybody's faces and get feedback on how quickly or slowly I am pacing myself. And so because of that, I tend to sort of default to a faster pace. And you should always feel free to ask questions, either by unmuting yourself and interrupting me. That's always totally okay. Or you can use the chat. I have the chat window open, or raise your hand in Zoom, and I'll get to your question when it's a good stopping point. So always feel free to stop and ask questions that way. The last time, we were getting into the groove of things by talking about the Unix shell. And again, we're using the Lambda server in this class to do all our work on. It's a Linux machine, and we're going to be automating basically everything that we're doing in this class using the Linux shell. And then this week, we're going to be introducing this new tool called Docker, which sits sort of on top of the Unix shell. And that's sort of the first 3 weeks of this class, getting this automate stuff system down so that when we get to the real data processing part of this class, you don't have to do things manually all the time, that you can be really efficient. And yeah, always like to automate things. Computer scientists, we are lazy people. I am lazy people. You should think of laziness as a good thing. And we should take advantage of that laziness, make the computer do the work for us. Humans are too valuable. Before we get into the actual material for today, though, I have a few quick set of announcements for us. And so the first thing, about 10 students so far have finished the lab from the first week. And so just as a reminder, there is no late penalty for this first lab or this first homework assignment. But in general, labs are going to be due on Sundays of the week that they're assigned. And if you somehow collaborate with other students, then you get the 2-day extension. So the sort of, I guess, nominal due date, assuming collaboration for last week's assignment, would be tomorrow. But again, if you don't meet that tomorrow deadline, you should try to meet it. But if you can't meet it for whatever reason, no late penalty. You should try to get all of the lab material from last week, though. Try to get it completed sometime this week. And if you don't, then you should start feeling like you're a little bit behind. But if you don't have it completed yet, don't have it completed tomorrow, that's okay, you're not behind. A lot of people have been using GitHub issues to ask questions in class, and that's great. That's exactly what the GitHub issues are for. And so as a reminder, up here on the top of our class webpage, there's this tab over here, Issues. And I've been posting different announcements here about whatever I need to make announcements about. And then a handful of students have also asked questions here. And you should always feel free, anytime you have a question and it's after hours or something, to just post your question here. And then I'll get to it as soon as I see it. Or, well, there's a number of advantages of having our using GitHub issues to ask and answer questions. One of them is that, so besides me and you being the only people interacting on the question, other people get to see and interact with the question as well. And so somebody besides me might see it first and answer the question for you before I get the chance. Also, it's very likely that other students have the same question as well. And by posting it to GitHub issues rather than email, we'll make sure that everybody's able to get that question answered. Also point out that, or one thing that I'll ask of you all is that when if you do get your question answered, don't go ahead and close the question. Don't close the issue, just so that that question stays up for a reasonable amount of time, so that other students have the chance to see it and possibly learn from it. Once I feel like the question is sort of old enough that it's not really relevant to class, I'll go ahead and close it. And another reminder is that you'll want to be watching this class repo. One of the first steps in the lab from last week, again, is to make sure that you have a GitHub account and that account is watching this repo. And that ensures that anytime an issue is posted, whether it's by me making an announcement or another student making a question or an answer to a question, that you will get an email about that and you'll be able to easily follow along with all the information that's going on in class. In this class, we'll be using Sakai only for grades. I'll be uploading your grades into Sakai, but we won't be using any sort of the announcement features of Sakai. I won't be sending emails to the class ever. Everything sort of material-wise is going to go through GitHub. And again, lots of reasons for that. One is it's just a better collaboration platform in general, but two, it's going to, anytime you're going up for interviews with recruiters, they have just simple programs that track your GitHub profile, how many issues have you made, how many people have you replied to, how many repositories do you have, things like that. And so by using GitHub in our class, it's going to be helping you build your GitHub profile, helping you when you go to these interviews, sort of pass the initial screenings, and then give you cool things to talk about with the interviewers while you're in the actual phone interview or in-person interview. And again, GitHub and Git more broadly, super commonly used tool in professional computer science, data science applications and companies. And I personally don't believe in having us use tools that are just one-off that you're only going to learn from this class, use for this class and never use again. I want us to use more general purpose tools that you can apply for, that are going to be with you for your entire career and that you can benefit you outside of this class. So that's why we're using GitHub in this issue system. Let's see, there's, so besides me and other students who might be posting on GitHub in the issues, we have 2 TAs for this class. Unfortunately, they haven't, well, let's see, one of my long-standing frustrations as one of the few computer science people at CMC is that it's the hiring process for TAs and things is not as smooth at CMC as it is at HMC or Pomona if you've taken most of your classes there in the past. So the TAs haven't been officially hired yet, and so I can't officially introduce them, don't want to make them be doing work that they don't get paid for. I'm not allowed to do that for good reasons. But as soon as I can, I will introduce them to you, and then you'll be able to go ask them questions. Any questions on any of that so far? Anything big picture about the class? Justin.
Yeah, sorry, I accidentally did the clapping hands reaction, but I was wondering on Sakai if you could, for like the labs and the homeworks, make it so you could resubmit answers. I noticed that I think I had an error in the lab 1, part 1, but I can't resubmit my original text response. So
yeah, that's a good question. I wish I could. There's various reasons why it's it doesn't really work out that for me to be able to let you resubmit things. And so if for whatever reason in this class you submit something, you realize there's a mistake, then that's a good time to send me an email and just say, sorry, I made a mistake on the submission. But there's, yeah, Sakai is not quite powerful enough with its settings to let me have the resubmissions and um, have the late submissions work the way that I want them to. So I want to keep the late submissions without having redoing the resubmissions. So yeah, I don't know if that the Sakai explanation of why it is the way it is makes sense, but if you do have short answers, if you do have a mistake with the submission, just send me an email and I'll get that fixed for you. That's a good question. Adi?
Yes, I had another question. Do we have a pre-class before every class, just to like review the lecture before the lecture is given?
I'm not sure what you mean by a pre-class.
I was going through the week one README, and it has like for the Wednesday lecture, like the pre-class, and I don't know if for actually for the lecture for today, I didn't do like the pre-class. Like there was like a recommended video, and I don't know if you're supposed to do that.
Okay, yeah, good question. So I'm going to scroll down here a little bit. Under this Docker section, we're probably not going to get to this today, but Wednesday we'll be going over Docker. There's this pre-lecture work, and in particular, a couple of videos here to watch, and then this assignment right here to install what's called rootless Docker. And there's instructions right here on how to do that. For today, there was nothing that you needed to do before today's lecture. These videos up here, what they're designed to do is just to get you some more big picture familiarity with this is a little bit about what we'll talk about today in class, and then this get you prepared for Wednesday. This is so that you'll be able to follow along in the terminal as I'm running the commands about Docker if you want to be able to follow along. There's going to be a handful, not too many times in this class where I'm going to have some sort of like pre-class assignment for you to do. And I will always announce those, talk about them in class, the class period beforehand. So there's never like something where you have to just be checking before class to do something. I'll always make it clear that you need to get this task done before the next class, if there is something that way. So for the next class, it's like 10 minutes of videos up here to watch. And then this could take, if everything goes smoothly, it's just a 5-minute process. If there's some weird errors or something, it might take an hour or two. If for whatever reason you can't get it installed, then that's okay. The main purpose of this is so that you'll be able to follow along with what I'm doing in class. Did that answer your question?
Yeah, that makes sense.
Okay. So then one last announcement is we're going to have, I've scheduled our first quiz, which will be a week from today, next Monday. So the first class period that we have back in person. I feel a little bit conflicted about the fact that sort of our very first day in person, I'm having a quiz. And so if people feel if people don't want that, I am open to a pull request to this repository that changes this due date on the quiz from Monday to say Wednesday. But tentatively it's Monday just because we have a fast schedule and I want to make sure that we don't fall behind. For any of the quizzes that we do have in class, basically the quizzes will always happen at the very beginning of class. And one of the things that I think is important with these quizzes is that nobody feels any time pressure on the quizzes. And the way that I'm going to ensure that that happens is that I will arrive in our classroom at least 20 minutes before the start of class. So I will be in the classroom at least by 7:50. And you're welcome to come early and start the quiz and have all that extra time if you would like to, and that's open to anybody. And this quiz is something that you'll have to be in person to take it. No Zoom. Yeah, no, it's not a remote quiz. If for whatever reason, for any of our quizzes, this one or any future quizzes, you're not able to be there in person, for this one, maybe you might still be stuck traveling, or different people throughout the semester might have quarantine issues or being sick, then just let me know and we will reschedule a different time for you to take that quiz. That's okay. But the quizzes will all be in person. For this quiz, there's a quiz folder in our week 1 folder in the repo right here. Click on this quiz right here. And then this PDF file contains the sort of instructions for the quiz. We'll go over that here in a second. And then these 4 SH files are sort of like the main, these are some sample questions for the quiz. And we're going to spend most of today going over all of this, the things that you need to know for the quiz and the format of the quiz and those details. So if you have questions about exactly what's going to be on the quiz, save those for after we've talked about it. Okay, so all that said, that's our announcements, administrative stuff, and we're going to dig into the material. We'll have sort of maybe 5 minutes of just sort of like historical review kind of stuff, things to set the context for us with the material that we're going to cover today. And then I'm going to switch back over to the terminal and we'll get into hardcore technical things today. So the first thing, there's 2 definitions that we're going to go over. And in this class, I am never going to so on these quizzes, I'm never going to ask you to repeat a definition or anything like that. All the things that we're going to be doing in class that you'll be tested on are much more practical. But these definitions are just sort of like background knowledge and useful things to know. And so this is the difference between the terminal and the shell. And these 2 terms are sometimes used interchangeably by programmers, but specifically the terminal is the actual graphical program that your computer uses to display the shell, to display the things that you type in. And for technical reasons, that's actually called it's actually a terminal emulator that what you're using. A terminal is a physical device. A terminal emulator is a piece of software running on your computer. But you'll hear people use both of these 2 terms interchangeable, and that's okay. And again, this is the software that's running on your computer, not on the Lambda server. So the terminal for all of our computers is going to be different. The shell, however, is something that's running on the Lambda server, not on your computer. So we're all going to be using the same shell program. And this is really just a thin wrapper around the operating system, a way to interact with the operating system in a convenient way. Historical background on the different types of Unix shells. So Ken Thompson, we had a video that for last class Friday that you were supposed to watch that had some historical background on Unix. Ken Thompson was one of the speakers in that video. Super famous guy, basically for inventing Unix. And so he invented the first Unix shell SH in 1971. This is inspired by what's called runcom shell. If you've seen these RC files, like the vim RC file and the bash RC file, which the last lab had you interacting with a little bit, RC files are basically configuration files for different programs. The RC comes from this runcom name, and this is a really old system back in 1963. Since then, since Thompson created his Unix shell, there's been a number of sort of famous shells that have come along. Or proprietary ones, and the most important of those is the Bourne shell in 1979. These days, nobody uses proprietary shells. Everybody uses open source shells. The Alchemist shell was an old one, one of the earliest ones, 1980. But then the Born Again shell is Bash. That is the most famous one. It's what we're using in class. When you log into a Lambda server, you're logging into Bash. And this Born Again shell is part of the GNU project. You'll see these 3 letters, G and U, thrown around quite a bit in this class. It's pronounced GNU, so not new like the animal, but GNU. It's one of the sort of shibboleths that lets people know, like, if you're in the club of hacker cultures, that you pronounce the G. And this GNU project has a lot of, it's a very political project, has a lot of, I don't know, political, semi-religious ideas inside of it. And so this Born Again shell, the name comes from the fact that it's from the born shell, but it's like you've had a born again experience, like phrase often used in religion. And so you've been awakened to the awesomeness that is GNU. This man right here, very famous, Richard Stallman, anytime we say the word Linux, he would like to interject for a moment and make sure that we are saying GNU Linux. So I'll let you read his diatribe here at some point if you'd like. We'll also be interacting with the Dash shell at different points in this class. Explain more about what that is in a little bit. But if you're on a Mac, you might have seen ZSH before. That's the shell that's on the default on Mac. The main takeaway from all this is that there are a lot of different shell environments. They all have some slightly different varieties, different things that they're capable of. And so about 30 years ago, people got together and said, there's too many shells. We need to make a standard, which we will call the POSIX standard, that all shells are going to behave, follow the POSIX standard. They can have their own extensions that do different things, but POSIX is, everything must do the POSIX stuff. And our quiz that's we're going to be talking about today, and everything that we're doing in class, we're only going to be limiting ourselves to really POSIX operations. Generally, anytime I'm writing shell script, I try to keep things POSIX compliant so that my shell scripts are as portable as possible. But there are some times when I have to dip into bash features. But I think everything in this class is going to be POSIX compliant. And we're going to be seeing here in a little bit that there are lots of, like, at first things are really easy, but there's lots of really weird edge cases. And so you will, your eyes might pop out of your head just like this, guys, when we get to the things on your quiz here in a little bit. Last thing for us to cover before we dive into the technical bits, there are some non-POSIX shells. The most famous of those is the friendly interactive shell, the fish shell. This is probably the main contender to the bash shell at this point in terms of popularity. But since it's non-POSIX, it breaks all sorts of backwards compatibility things. And so I don't see it taking over anytime soon. We're going to be in a bash world for the foreseeable future. Okay, so into the technical details. Over here, let me make sure that we can all see my entire screen. There we go. I'm logged into the Lambda server right here. pwd prints our working directory. I'm in the user test home folder. Who am I? Tells me my username. So I'm currently logged in as user test. This is my home folder. And if you remember, we had this cd prod cmc/csci 143 folder, which is where the GitHub repo is stored. And I have all the things, all the class material for us. If I type ls, so here's all the information in the repo. Let's also go into our week 1 folder like this, and I type ls. And you can see that I only have 2 files here in this week 1 folder. We're going to come back over to Firefox here for a second, scroll up, and here you can see there's a lot more files that have been added to this week 1 folder. And so what I'm going to go through next is how I can update on my Lambda server, my class repo to contain all of this new information inside of it. And that's a git command. Anytime we're updating our Git repositories, a git command. And the particular command we'll use here is git pull origin 2022 spring like this. And so I'll just scroll up a little bit so we can see what I typed in here, explain what's going on. The git pull command takes something from GitHub or from some remote Git repository and moves it onto your local computer. Origin is the name of my remote repository. So it's the particular Git URL that I'm extracting things from, and then it's the 2022 Spring branch. So the branch for this particular class. And it's updated a lot of different files here, gives us a nice summary. And then I type ls, and we can see that we have all of these different files added down here. I'm going to pause now at this point and take questions. There's a good question in the chat about what exactly is the difference between upstream and origin. And when you're using this git pull command, so upstream is another remote that you could put right here. You could put upstream instead of origin. And the difference between upstream and origin is really one of convention. Right here, I'm in the terminal. I got to this particular line by using the up arrows to go back to through my bash history to see what the previous command was. I want to leave this command though without actually running it. If I were to hit enter right now, it would run the command, but I don't want to run the command again. So I'm going to press Control-C just to get a new terminal line right here that I can enter something into without running the git pull origin command. So this right here is what's called a remote in Git terminology. So git remote lists all of the remotes that I have. And currently I only have one remote, the origin remote. If I do git remote -v, the -v stands for verbose. And origin is just a shortcut for this URL right here. So anytime I do git pull origin, it's git pull from this giant URL. This is just a shortcut for basically copying and pasting this URL right here, saying this is the location that you want to pull from. You can add other remotes. So the command would be git remote add, and again, the lab from last week walks through some of the details about why you might want to do this. The main sort of workflow that this comes up in is when you're working with pull requests and issuing a pull request to another repository. You can add another remote, another URL basically that you're working with. And traditionally the upstream, so traditionally upstream is the URL of the repo you forked, and origin is the URL of the forked repo. So upstream is the one that you don't actually have permission to write to. Origin is the one that you do have permission to write to. So you can pull from this. You cannot pull to. You cannot push to this. You can only pull from it. Origin you can push and pull. Upstream equals pull only. Origin equals push pull. This is all just 100% convention though. All of the only thing technically that origin and upstream are is they're shortcuts for this URL over here. And so there are other workflows that could have different conventions. But for the standard pull request convention, that's what origin and upstream are for. Again, this hashtag is a comment in the shell. So bash shell or dash shell, all the different shells. And so these, I'll be using comments in class just to type out, give you a visual view of what I'm saying occasionally. It's a great question. Hopefully this answer maybe filled in some gaps for some people about what exactly these terms mean or are doing. But again, the lab from last week is where this material sort of originates from. And if you do have questions, more detailed questions about this, then office hours is a great chance to like really dive in and get those questions answered. Great question. Any other questions so far? Okay, so then we're going to go into this quiz folder and take a look at these files right here, these sample quizzes right here. And then after we do that, we'll take a look at this PDF in particular. So again, on the terminal, anytime I'm using the terminal and I want to open a file, Vim is the text editor that we'll be using in this class. So it's Vim and then example 1.sh. Again, I am lazy. My fingers are, they get tired easily. I don't want to get arthritis in my fingers. So I don't want to type out that whole word example. That's just too much work. So instead, I just type out the first few letters and then I press tab, and tab completion in the bash shell completes that for me up to the spot where it is no longer ambiguous. So it gets example, and then there are some numbers, 1, 2, 3, and 4. I have to select which one of those numbers I want. We'll start with number 1. I'll type a 1, and then I'll press tab again to get the .sh at the end. In every system except Windows, file extensions mean nothing to the computer. So everything over here after the dot is called the file extension. I'm gonna press Control C so I don't actually enter Vim right now. .sh is the file extension. It is only for human consumption. It just gives a hint to people to the human, to the user of the computer about what this program is going to do. And .sh is for shell scripts. So any of these bash, dash, ash, zsh, fish, all of those programs, if you're writing a script using those systems, they all end in .sh. But again, the computer doesn't care. It's just convention for us puny humans. So Vim example 1.sh. The very first line of this file up here, right here, this is called the shebang. First line, line 1 above, is called the shebang. Shebang, where the origin of this name, here we have hash. So it's hash, like that. And then computer scientists, we're lazy. This is not an exclamation part and not an exclamation point because that is way too many syllables. I can't even count that high, how many syllables that is. So that is pronounced as the bang to computer scientists. So this used to be called the hash bang, and then hash bang, shebang. You forget the hash, and you really don't even have an E right there. It's just shebang like that. That's where why it's called the shebang. And what this does is this is the actual line that tells the computer what program to execute this script with. bin/sh in the Lambda server, and the vast majority of Linux systems goes to the dash shell. So /bin/sh is the dash shell. When you're typing directly in the terminal, that's the bash shell. So dash, it should sound like it's fast to you because it's dash, the Debian alchemist shell. And dash only supports POSIX commands, which makes it a little bit faster than bash because it doesn't have to handle all sorts of weird different edge cases. And so that's why it's the default shell for most Linux environments, because it's faster. But it's a little bit less featureful. We'll ignore this for now. And actually, we'll ignore everything up to, okay, yeah. Ignore this for now, and we'll get back to this later. When we run one of these files, then the way the computer is going to interpret this file is it's going to just take each of these lines one by one and basically copy and paste it into your terminal system and executing those lines. And so in your quiz, what you're going to have to be able to do is I'm going to give you one of these files, and you'll have to be able to mentally execute what each of these commands is going to do and output the results. So you can see down here, it says echo problem 1. So all of this stuff right here is the information for problem 1. And then down here, let's see, all of these commands have no output. They don't print anything to the screen. The last command is the only one that prints something to the screen, and you will have to print out what it actually is that gets printed to the screen. So let's go ahead and I'll do WQ to save and quit this, and we'll run this this shell here in a second, and we'll see what the answer to this first problem is by saying what the output to this line is right here. In order to run one of these commands, so first of all, you'll see that these are highlighted in green. That means they are executable programs. Green means executable. And another way that I can know that they are executable is, again, with this ls command. If I add this -l flag to ls, it lists all sorts of extra different information about it. And this x over here in the permissions means that the program is executable. Again, over here, this is user, group, and everybody. So everybody is allowed to read and execute these files, but only, this is the user, this is the group right here, only the user test, me, user, is allowed to actually write to these files. In order to run this file, because it is executable, one thing you might be tempted to do is just type example1.sh like this, and if you do that, you'll get something saying command not found. Doesn't work. In order to run a program that is in your current directory, you'll have to do /example1.sh like this. So the / says, look in the current folder that you're currently in, and then run this command right here, assuming it's an executable. Hit enter, and this is the output of the results. So we see there's 6 problems right here. The answer to each of these problems is just a number, and so on your quiz, you'll have to you just write out exactly what is the number that is the answer to that particular problem. Yeah, so what we'll go about next is actually seeing how do you understand what's going on in each of these problems and come up with the correct answer. But before we do that, are there any questions at this point?
I have a question. For the quiz, can we use our like the command reference cheat sheet?
Yeah, great question. So for the quiz, and all the quizzes that we're going to have in this class, it is 100% open note. Let's go ahead. I'm going to open up the quiz.pdf file, which has the actual instructions for the quiz on here. And at the very top right here, it has the rules about what you can and can't do on the quiz. And so you can use any printed or handwritten notes on the quiz that you would like. So that includes the cheat sheets that that I gave you in week 0. That includes these 4 example quiz files. If you want to print them out and write out what the answer is and how to get those answers, you're totally allowed to do that. That's totally okay. The main things that you're not allowed to do, you can't use a computer in any way on the quiz. So that's basically just preventing you from typing in the answer or typing in the actual question on the computer and seeing what the answer is directly. So if you do want to have access to any notes or something, you must print out those notes or handwrite those notes out ahead of time. And again, those notes can be whatever you want. You could bring in textbooks, you can print out the entire internet, and as long as it is on paper, then you're good, you can use it. You just can't consult a computer during the quiz, and you also can't consult another human during the quiz. Did that answer your question, Dustin?
Yeah, thank you.
Okay. So let's see about how to go about answering these questions. So let's go ahead and I'm going to open back up example1.sh. Yes, and we'll gonna skip all of these things here, and we'll start with just problem 1. So the echo command, what the echo command does is it takes as input whatever you pass in over here, and then it outputs it to some particular echo outputs to standard out. Let me write this out. So echo outputs to a location called standard out. This is how we write standard out, but that is pronounced standard out. And then the greater than sign called output redirection. So normally standard out goes to the terminal. Normally std out is the terminal. With this, instead of standard out being the terminal, output redirection changes standard out to a file name. So it changes it to readme.md. Similarly, that also is output redirection, takes the result, saves it in readme.md. The double greater than sign appends, single greater than sign erases the file, then writes. So here, what's going to happen is when we do echo hello world into readme.md, it's going to create the file and add hello world as the first line in the file. Then when we run this command right here, it's going to not delete the file because it's doing the double greater than sign, and it will add hello world to the end of the file. Going to leave them for a second and show how this works. So hello world into readme.md. We can use the cat command, cat, to print the contents of a file, cat readme like this. I use tab completion right there to make sure that I didn't have to type out the whole readme. And if I rerun this command, you'll notice that the length of the file never changes. It's always exactly the same. If I use the double greater than sign like this, though, you can see that every time I do this, the length of the file increases by 1 because the double greater than sign does not delete the contents of the file at the beginning. This third command down here now uses the greater than sign again, putting it back into README. But because it's the single greater than sign, it's going to delete the contents of this file. And so there's only going to be a single line in this file. So therefore, when we run cat readme, recall that cat readme is going to print the results of the readme.md file. We'll pipe the results of those to the wc-l. We saw last time that wc-l counts the number of lines in its input. Its input comes from the output of cat readme due to this pipe right here. And so we're counting this right here, counts the number of lines in the readme.md file. So let's go ahead and do that. We'll see that there should only be a single line in the file because this is really the only command right here that matters because it deletes the contents of the file when it runs. So /example1.sh, the answer to problem 1. Where's my cursor? There it is. The answer to problem 1 is 1 because there's just one line in that readme.md file. If we look at, so example2.sh, we can see there's different combinations of these greater than signs. Example3.sh, more combinations of these greater than and less than signs. And example4.sh, other combinations. And so the purpose of this first problem right here is to test basically your understanding of input and output redirection. Question, Matthew.
Is there a difference between the single quote and the double quote and no quote in the hello world?
Yeah, great question. So another part of this first problem here is there's single quotes, double quotes, and no quotation marks, and understanding the difference between what exactly these things mean. And in order to see what these mean, we're going to, let's see, the confusing part about what these mean is that it's interpreted by the shell before it gets passed to the program. And we're going to, in order to see exactly what these mean, I'm going to write a very simple Python program that will help us out. So let's open up, call it args.py because we're looking at command line args. And let's do import sys and sys.argv, print that out like this. So this is a very simple Python program. Sys.argv right here stores the actual arguments that get passed in to the program, and we print them out. And this is going to be, we will eventually get back here to what these single and quotation, double quotation marks mean. We're just taking this little detour so that we can walk through and explain this well. And go ahead and run this program. It's a .py program. So again, to run that, it'll be python3 args.py, hit enter, and here's the output of this program. If I add some more command line arguments like 1, 2, 3, 4, 5 like this, we can see that this list right here in Python contains all of the things that I put over here in the terminal. The very first argument to in the list args.py, so sys.argv of 0 is always the name of the file that got run, and then sys.argv of everything else is the actual command line arguments that you can do things with. And so what we're going to, whoops, Python3 args.py. What we want to do is see how do quotation marks affect what gets passed into those arguments in the terminal here. So Python3 args.py, if I add quotation marks around some of these things, so like 1 and 2 like this, then you can see that there's no difference between having these quotation marks and not having these quotation marks. Either way, the parameter that gets passed in is a string, and that quotation mark means nothing. So quotation marks are processed by the shell before the arguments get passed to the program. And the quotation marks will never actually be something that happens in the program. The main purpose where you want to include quotation marks is when there's a space in your arguments like this. So 1, 2 like that, I hit enter. Now you can see this 1, 2, it's a single parameter to the args.py program. This is sys argsv at position 1 right here, contains the string 1 space 2. If I did not have that space, or sorry, if I did not have the quotes, then it looks like this with a 1 and a 2 separate. How this affects us with the echo command. So example 1 right here, we're using this echo command. So how this affects us with the echo command is if I do something like echo hello world like this, we get hello world. Echo just takes in its parameters and outputs them separated by spaces. So this is the first parameter, this is the second parameter, output first parameter here, second parameter here, separated by a space. If I add a bunch of spaces like this, you see that we still get the same exact output down here because the echo command doesn't see anything different. The shell, bash or dash, will interpret this as, it does the interpretation for us, putting this into argv position 1, world into argv of position 2, ignoring all of these spaces here for us. The echo command, whatever the program is right here, never even sees, it's never even aware of these spaces. If I put this inside of quotation marks like this, single quotation marks like this, then it's aware of those spaces. This entire thing is the first parameter, and all of the spaces are included like that. If I use double quotation marks, we get the same exact output at this point. The difference between single and double quotation marks has to do with what's called variable expansion in the Unix shell. So the shell is a fully featured programming language, just like Python, C, Java, any other programming language you might have used before. And because of that, it contains variables. So I can create a variable, something like var equals hello world, like that. And then I can do echo $var. The equals is assignment, just like you're used to from other languages. But then the thing that's a little bit different between the shell and most languages that you've seen before is that in order to access the variable, you must put the $sign in front of the variable's name. So echo var actually just prints var, echo $var prints out the contents of the variable. So put the $sign in front to access the variable. And if we do something, well, this begs the question of like, what if I actually want to pass a $sign to a program, pass it to echo? If I do echo again, $var, this $sign is not going to be passed to echo. If I put it in double quotation marks like this, also not passed to echo. If I put it in single quotation marks, the shell does not interpret anything inside of single quotation marks, and so we will get the $var like this, $var. What's the difference between this and this? That depends on the contents of var. So if I say var equals hello with a bunch of spaces, world like that, then echo $var. Bash does the $sign substitution before it calls the echo program. So, or before it calls our Python program, Python args3, $var like this. And we can see that $var gets expanded into hello world. So this is entirely equivalent to this command right here. This $var gets expanded into hello world like this. And then hello and world are passed separately as parameters to args.py. If I put it inside of the double quotation marks, then it does the expansion just like it did up here, but now that expansion is contained in the double quotation marks like this, and so it gets interpreted as a single parameter to the program like this. So up here in our first problem, it turns out there are no differences between any of these three things, because what we care about when we're counting the number of lines is how many lines get output by echo, and all of these output the same number of lines. Question, Axel? Any other questions at this point? There's a lot to take in. And so again, if this is feeling fast to you, if you haven't seen any of these things before, then that's okay. You're not behind. It just means that this week you'll have a lot of work to do to catch up. Dustin, question.
Yeah, so for the answer to number one, it's one line. So since it seems to be piping, or not piping it in, but like putting that into, what was it? Like this README. So the answer to number one is one. So does it not create new lines then each time you put it into the README?
Yeah, so echo always outputs a new line at the end. And so at this point, after this line, we have one line in readme.md. After this line here, we have two lines in readme.md. The difference, we have the double arrow right here, the double greater than sign, which means that we add this output to this file here without deleting the contents of this file first. Whenever you have the single greater than, you first delete this file and then you output. So the reason the answer is only one is because this line right here deletes the previous contents. And so it doesn't matter what we had up here. We could have had This file could have been hundreds of gigabytes in size, but because we have this, it immediately deletes it, and then echo only puts a single line in. So that's why the output is 1. Did that answer the question?
Yes, thank you.
One last subtlety with these double quotation marks and single quotation marks that's going to come up in some of these first problems. So if we think it's example 2 where this comes up, here we have this $ again, but it's the $ parentheses. What $ parentheses does is it executes the command inside of the parentheses. So if we have ls, this is the contents of my current folder. That's what ls does, is it lists the contents. When I do echo ls like this, ls right here, it runs the ls command. Here's all of the output from ls, and then it puts that as a string right here. And so all of those things get passed as an argument to echo. And so that's why we have all of these different files right here as the things that are being echoed out. If I put that in single quotation marks like this, then you can see that it doesn't do anything. It doesn't interpret the $ at all. If I put those in double quotation marks like this, then it puts all of those on their own individual line because ls is outputting things onto its own individual line. So those are edge cases that you'll have to think about with this example 2.sh with these different quotation marks right here. Here in example 2, or in, yeah, it's example 2.sh, problem 1, you can see that these files begin with a dot. And in the Linux terminal, files that begin with a dot are special files called hidden files. Files beginning with a dot are hidden files. And they're hidden in the sense that ls does not by default display them. So ls like this, you can see that all of the files that it's outputting right here do not contain a dot at the very beginning. If I do ls-a, the -a stands for all, and it will display all of the hidden files. And so here, there's just 2 hidden files, the dot file and the dot file in this directory. Both of these are special files that refer to, dot refers to the current folder, dot refers to the parent folder. So in this case, dot would refer to this right here. pwd, this is my current folder. That's what dot is. This is my parent folder. So if I did cd pwd, that's what I get. Now back to quiz. If I created that README file, so touch.readme.md, so again, begins with a dot, ls does not display. We have the normal readme.md from before. You don't see the dot readme.md, but if I do ls-a, now we have this dot readme.md. So in the quiz, you'll have to be careful about whether I'm doing ls-a or ls to know whether you should be including these hidden files or not including these hidden files. There's a good question in the chat right now about, so we mentioned before that the greater than sign overwrites the previous file. And the question is there a way to recover the file that you overwrote if you did that by mistake? And the answer is not easily. If you overwrite a file, you should consider it as being gone forever. You should consider it as being gone forever. Potentially, that's not technically the case, and if the file was extremely valuable, you could hire somebody for about $2,000 an hour to go through and manually look at the bits on your hard drive and try to recover the file, but it's an extremely expensive process and very likely not to recover it. So you should think of, just like if you deleted the file on your computer on accident, using the RM on accident, you should just think of it as gone. Good questions. Any other questions so far? Okay. So yeah, problem one you can see here is testing a lot of different things, and all of these problems are sort of, I think of them as integration problems, because they're expecting you to integrate lots of different knowledge about lots of different aspects of the Unix shell in order to get the answer correct. And in some cases, like in this case, the quotation marks, it's just sort of a red herring. It's not actually really part of the problem. It's really the output redirections that you have to pay attention to. But lots of things going on here. All of these problems end in a somehow catting something, piping it to wc-l, so just counting the number of lines in a file. But they all test slightly different things. So problem two down here is testing your knowledge of Git and how Git internally stores things and reacts to things. Here, so we're using output redirection here again to this special file /dev/null. So dev/null is a special file that just eats the input and does nothing. So this is a common pattern, output to /dev/null. If a program has some sort of output and you just don't want it to be displayed to the screen, like it's in the middle of a script, so you don't want to confuse the user, you just redirect to /dev/null. This is also redirection. You don't have to, for the quiz, you don't have to know what the difference between the 2 greater than is and the regular greater than. But the technical answer is that 2 greater than redirects something called standard error to the specified file. And standard error is like standard output. Every program, when it's started in Unix, has 2 different output streams that both go to the terminal, standard error and standard out. And standard error is supposed to be for error messages, standard out for non-error messages. And this just says redirect both of those things. Absolutely all outputs go to dev null, so they get deleted. The only purpose of these lines right here is just to so there's no output from Git init in the result of the script. And then problem 2 is testing how does the git add and git commit interact with all of this. And so you'll have to be able to understand your git commands and what they're doing in order to know what the output of this program is right here. Problem 3, also relating to Git, but adding in checking out branches. And so this is creating another file down here, adding it, touch creates another file, committing them, and here we did not add the example file right here, so it did not get committed. The README file did get committed, and so when I check out master, was a new branch going back to master. When I do this commit right here, example will stick around. So this file is never added to Git, so checkout doesn't delete it. But up here, README was added. README.md was added, and so it will be reverted on checkout to master. In this particular example problem, up here we have just readme.md. Down here we have readme as well. So this README is getting added to the master branch, and so it will continue to stay around when we check out master. But some of the other example problems, example quizzes have different files here, and so they will not stay around. So you have to pay close attention to those files. But problem 2 and 3, basically just testing your understanding of Git branching and how those interact with things. Problem 4 and 5 are related to understanding how for loops work in Bash and the Unix shell in general. For loops are a little bit confusing, so we'll take a look at that here. Going to come back over to the terminal down here and do a quick for loop. So it's for I in this I right here. This is the name of my looping variable that I'm iterating over. And in Bash, in the Unix shell, everything is just a string. So I'll do, for now, 1, 2, 3, 4, echo $I, do echo $I, done. And this is the standard syntax for a for loop, that you have the for loop, semicolon, do, then you have the command that you want to repeat multiple times, and then you end it with done. Hit enter, we get 1, 2, 3, 4. This I variable right here gets the way the shell knows which things to loop over is because they're separated by spaces. So those are the 4 different things. And this is exactly the same way that arguments work. So if we had a bunch of extra spaces between things like this, the shell totally ignores them. And it's just, these are sort of like the 4 arguments that get passed into this I variable. We can surround things with quotation marks, single or double quotation marks. And it works just like it works when passing things to as arguments to commands. That now this 1 and 2 is a single parameter that gets passed right here. This 3 and 4 is also a single parameter that gets passed right here. It's a little bit confusing because, let's see, oh, that didn't work. I'm gonna do a quick, some quick magic right here to make everything fit on one line so we can see it all. This PS1 variable is a special variable that controls what the shape of my prompt is right here. Set it equal to just the $sign so that it's not taking up my whole screen right now. And so here, this $sign is just where I can, it's my prompt indicating that I can type things in. I just made it shorter so that I can type in this for loop and it will all stay on one line, and it's a little bit easier to read now, hopefully. But this 1, 2 corresponds to this 1, 2 right here. This 3, 4 corresponds to this 3, 4 right here. And this $I right here is this I right here. Notice what happens when I use the $I with the different quotation marks. So above is no quotation marks. Here is the double quotation marks. Here is the single quotation marks. Up here, when I have $I with no quotation marks, you'll see that this up here, this echo $I, the $I will get substituted exactly for 1, 2 and exactly for 3, 4 with all of these spaces in between them. But after the substitution happens, then Bash will pass these parameters over to this command right here, this echo command. So when we pass echo 3 and 4 right here, you might expect that all of these spaces would appear down here, but they don't, because when I is equal to this, if I say I equals 3, 4 like this and do echo $I, that echo is equivalent to echo 3, a bunch of spaces 4 like this, which is not going to keep those spaces around. So you have to keep those quotation marks around if you want those spaces to stick around. Yeah, when Bash scripting, understanding exactly what these different quotations are doing and ends up being sort of like one of the real tricks about Bash scripting. And if we come back over to our lecture notes back to this meme right here. You can see how there's what's going on and all of these different options is really just how quotation marks and things are interspersed through the results down here. And that's why his eyes are popping out of his head, because that's the trick to all of this, is understanding where to put quotation marks and where not to. Any questions about anything so far? Dustin, is your hand, is this another question or same question as before?
Oh, sorry, I didn't lower my hand. My bad.
Okay. Any questions?
Mike,
go ahead.
excuse me. For the double quotations, is it basically treating the 3 to 4 as one item?
So you're saying in this line right here, is the 3 and 4 being treated as one item? And that's exactly right. That the 3 and the 4 get substituted into this I doing the expansion. And then because it's inside of quotation marks, it gets passed to echo as a single item. We change this echo to the Python 3 args.py like this. Oops, with the double quotation marks. We can see that it is being passed as a single argument to the args.py. But if we took away those quotation marks, then it's being passed as 2 separate arguments to the args.py. Did that answer what you're trying to ask?
Yeah.
So that talks about everything that goes on with these first 2, or these problems 4 and 5. This one's a little bit maybe trickier because it's got this pipe right here on this for loop. And so pipe and output redirection in general in the shell, any valid terminal command can be to the left of a pipe or to output redirection. So this entire thing right here, this is echoing to the file all of the different arguments inside of the results from this ls, and then it's just counting those results. The last thing that you need to know is how this star works, and the star is called the glob. And what the star does is Python 3 args.py star. Python replaces star with all the different files in the particular path that you've specified. And if we put in a pattern like A, things that starts with A, args.py is the only thing that starts with A. If we do ex star, then here's the 4 files that start with ex star. And this glob expansion only happens when it's not inside of a quotation mark at all. And so this last program is going to have just different kinds of quotation marks interacting with these stars and testing that you can figure out what's going on. The only things that I'm going to be, yeah, next time I'll say a little bit more about this, but these problems, if you look at the 4 different example files, they're basically all exactly the same, except that I'm just changing like single quotation marks to double quotation marks, or removing a $sign or adding a $sign in different locations. So we'll talk next time about exactly what all the different formats of the questions might look like on your actual quiz. But if you can do these 4 example quizzes, then you will be in very good shape for the in-person quiz. And again, you can always check your work. You just run the quiz to see what the actual results are, what the numbers are, and make sure that what you think the results should be, you can check it that way. That's all for today. Again, you have the try to install the Docker command for next class, and I will see you all on Wednesday. If anybody has any questions about anything, I will be sticking around now to answer those questions. But otherwise, I'll see you all on Wednesday.
Thank you, Mike.
Thank you, Mike.
Thank you.
Dustin, question?
Yeah. Have you decided if you're going to move office hours later on? Because I know that some of the data mining students have,
Right.
or sorry, some of the data science majors have data mining like right after this.
Yeah. I know data mining conflicts, and so I am going to move office hours. I don't know what the new time will be though.
Okay. Yeah.
Mike, can I ask about my notation question?
I want to make sure I get all the class questions answered first, and then we can do the notation question.
Got it.
Daniel? All right, Yilin?
Can I ask a question about last week's lab?
Sure.
Let me share my screen first. So for the lab, I tried to use finger here, but I don't know what's happening here because there's no like mic is speaking there.
Yeah, so that account happens to not be logged in right now, so the answer would be 0. You can you can test that your command is working by putting in a different username. But the answer will be 0 right now because there's it's logged in 0 times.
Okay, I see. Another question is I tried to update the week 01, but it says here I don't know how to resolve this.
Yeah, am I remembering right that you had a pull request to the
Oh yeah.
Yeah, so I think what's happening is that you edited the README file on a version of the repo that's a couple commits old, and so now when you have a new README file, and I don't have those changes, and when you do the pull, it has changes to this README file from both you and from me and subsequent commits, and so that's why you're getting this merge conflict about not being able to merge it. So you'll have to resolve that merge conflict. It's also saying that when it says that you have local changes that would be overwritten, that means that you've edited that file but haven't committed the changes to that file as well. So if you do the git add readme git commit, then that'll take care of that problem.
So I kind of like do the pull request again, or
you'll have to redo the pull request in order for me to accept it. Yeah.
Oh, okay, I see. And I noticed that here it's like a plus equal, but here it's plus smaller than. What's the difference between the two?
It's related to whether your repository is ahead or behind of the upstream repository or the origin repository.
Okay, so it doesn't like influence much.
It's safe to ignore.
Okay, thank you. And another question about today's example 2. So here it's like $ parentheses ls. Where can we see, because we're using a temporary directory here, like how do we count ls, or it doesn't matter for this one?
Yeah, so the purpose of creating that temporary directory at the very beginning is so that it's going to be empty at the beginning.
Oh, okay.
If you want to, like, you can actually, so line 7, it has pwd, it prints out the name of that temporary directory, so you could cd into that directory and run ls yourself and just see what the contents are. But at the very beginning, it's going to be empty.
Okay. Wait, so if it's empty, then the line 11 will be like 0 line or?
It'll still add a line. It'll just be a blank line.
Oh, okay. Okay. Thank you. Yeah,
Mhm.
that's it.
Anybody else have a question besides Varun?
So mine's about the like logging into my Lambda server. So I don't know if anyone would want to ask anything before that.
Go ahead and share your screen and we can get that. Let's get the Lambda server.
So I can't. I try to share my screen. Wait, so share what exactly?
So I just want to see the steps that you're walking through to be able to log into the Lambda server. So
Okay, yeah.
whatever program you're using for that.
Yeah. Let's see. Share screen. So this is the hyper terminal, and I configured to use bash on Ming W. Let me see. So I could just, what was it? Minimize this screen. Yeah, then I changed the password, but the one I have right now doesn't work for whatever reason. So.
Okay, how about what I'll do is I will reset your password for you and paste a new one in the chat, and then you can re-go through that process of.
Yeah.
So let me get that set up for you here. And can you paste your email into the chat for me?
Yeah, I'll do that. Let's stop sharing this.
Perfect. Okay, I've reset your password and your new password. I've just put it in the chat window.
Write this down.
You should, so as soon as you log in with it, it's gonna ask you to reset your password again.
Yeah.
Yeah, so my recommendation is just go through, do that process and see if you can get it working. And
Yeah, I'll do that right now. Thank you.
okay, yep. Yulin, do you have another question?
Yeah, so I'm still a bit confused about the merge conflict.
Okay.
Because I saw on your on the CSCI 143 GitHub page, the README file already being updated. So I don't know like what's wrong. What do you mean by saying merge conflict?
Yeah, so on my repository on GitHub, it's been updated. Can you go ahead and share your screen with me and show me we'll walk through exactly what the error message is on your computer.
Okay.
And run the pull command and show me the output of the pull command.
So do you want me to rerun it?
Yeah.
Okay. I think it is.
Okay, yep. So this indicates that it's working correctly, and so probably whatever you did between the last time you ran it and now has it fixed.
Oh, okay.
So if you just :WQ right now, it'll save and quit out of the out of Vim, and this is your commit message for the merge.
Oh, okay. So it's like working now.
Yep.
Another question is when so I created another folder directory here called pull requests to store all pull requests there. So every time I do pull request, I change directory into the third one. But my main project file is here. Like it's where I do labs and homeworks. Does it will it work, or I should maintain the same directory?
I think it will be, so there's no need to have two separate folders. If that's what makes sense to you, it's okay to have that, but it makes more sense to me to have just one folder for the class.
Okay, I see. Thank you.
Anybody else have questions?
Yeah, I had a question about the lab. So I'm still stuck on the first part.
Okay.
Yeah, so I tried finger and then piping that into grep Miss Vicky, but
Can
it
you go ahead
seems
and
like,
share your screen so I can see what
oh
you're...
yeah. So I guess finger shows in everyone who's currently logged in right now.
Yep.
So there's like 2 instances where I'm logged in, so it shows 2. I'm not sure how to translate this into like the total number of times that you've logged in.
Oh yeah, so it's not the total number of times that you've logged in for like overall periods of time. It's just the total number of times that the person is currently logged in.
Oh, okay. So instead of my username, it would just be like this. Okay, I see.
I think, let's see. Oh yeah, I was just logged in, but then I logged out, so that's why it's back to 0.
Oh, okay. Thank you. And then I also had a question about part 3 on the lab. I
Okay.
think I'm having trouble figuring out how to write the command.
Okay.
Mm. So from here, do we say unzip and then geo Twitter?
And so you're getting permission denied right here because by default, the unzip command will save the contents of the unzipped file to the current location. And we don't want it to save it to the current location. Instead, we want to have it printed to standard out so that we can pipe that to future commands. And if you open up the man page for unzip, and do a search for standard out. So in any Unix terminal system, in order to do a search, it's a / and then type stdout and hit enter. And so here you can see if you pass that -C flag, it will print the contents to standard out instead of trying to save it as a file. So you
I
can do
see.
unzip -C.
Okay. I'll try that then.
I think it probably has to be the first thing.
Oh, okay.
Unzip -C, then the name of the file. So since standard out's currently your terminal, it's going to just go forever printing stuff on your screen. You can press Control-C to stop that.
Okay.
Then, but now if you do the piping that to the other commands.
I guess it'd be like WC and then by line. Or
So that would count the total number of tweets sent that day, but it's also asking you to filter it for things just containing coronavirus.
Oh.
So the grep command does the filtering, and then that tr command converts uppercase down to lowercase so that you can, whether they capitalize coronavirus or lowercase coronavirus, you'll get a match.
So I'm assuming you should first translate the letters first.
Yeah.
I see. And then type that. Oops. Not sure what I did.
Press Control-C. So when it was printing all that junk to the screen before, it kind of messed up your terminal a little bit. You can type reset, R-E-S-E-T, and it will fix your terminal with that word wrap, get everything back to normal.
I see.
And you can, yeah. Now pipe that to the TR.
Okay, let me try that. Then to match on anything containing coronavirus, and then counting line by line.
Yep. And that'll take a minute or two to run, but I think that should be the solution.
Okay, I see. Okay, I'll just let that run, but thank you so much. That was really helpful.
Do you have any questions about like the process of how we worked through that, figuring out what the right arguments or things were to the different?
Yeah, I think I'm still a little confused about like where you put like the operators or like the minus and then the letters and all the order. I guess I'm still like confused about how to figure that out.
Yeah, maybe So the principal is the man page to find exactly what the particular like flags are that we need to get it, and then let's say I think I don't know, based on the hint right there, did that make, I think it, like the hint said first do the unzip, then the tr, then the grep, and then the WC.
Yeah, I
and
guess
so,
I
yeah.
wasn't able to figure out how to deal with the permissions issue on my own.
Right. I think just seeing more examples is usually what helps for those sorts of things.
Yeah. Okay, well, thank you so much.
Yeah, you're welcome. Chuck, did you get get logged in?
Yeah, I just did. I literally just did. Thank you.
Okay, perfect.
Yeah, yeah.
Was it Avi? I remember you saying you are having questions about getting logged into the Lambda server. You still
Yeah.
have the
Is it just like you? So the little like code that you sent me, do I just put that? So I have a Mac. Do I just put that in like that terminal app that we have that no one really uses?
basically, if you want to walk through it right now, you can do that, and I can just make sure that everything's going smoothly.
Yeah, for sure. Should I share screen?
Yep.
Is that right?
Yep, this is the right spot to be. You start.
Then
Yep,
just
exactly.
Oops.
Without the $sign, everything after the $sign.
Oh, gotcha. Then all this. Hold on. Where's the?
And then the 5055 is the end of the command.
Is it? So it's all of this, right?
But not the -bash on the next line.
Oh, okay.
That's it. Yep. And then type yes. That'll only come up the very first time you access a server. And now this is where you put the random password.
Oh, okay. How do you paste it in, or can you not paste it in?
So anytime you type or paste something in here, it's not going to display any results. So you paste just like normal, but it's not going to give you any indication that you pasted. So if you think you pasted, just hit enter. And so it worked. That's the correct output. So now when it says current Unix password, that's the same one that you just entered. And then it'll ask you for a new password.
Okay.
And so now you can type in your new password, what you want it to be. Okay, and now logging in again is that same SSH command that you typed in above, but it'll be the new password. Yep. And now you're in the Lambda server.
Great. Amazing. Okay. So
Any questions
what
about
is
that? Go ahead.
like, I'm sure you covered this in the lecture videos, but I am yet to watch it. But what's the point of a Lambda server?
So all the things that you'll be doing in this class are, you'll have to do them on the Lambda server. Basically your computer's not powerful enough. The smallest data sets that we'll be working with are 4 terabytes, and the biggest ones are about 50 petabytes.
Okay. Okay, sounds good. Thanks, Professor.
Yep.
Oh, if you're free 20, 30 minutes before class on Wednesday, I'd love to meet. Otherwise I can send you alternative timings.
Send me an email just to remind me, probably, but I'll let you know over the email.
Okay, sounds good. Thank you.
Mike, I have a question regarding example 1.sh. So in problem 4, when we do echo hello world to directory /file, so that is the same as do echo hello world to readme.md.
Can you share your screen so I can just make
Yeah.
sure I'm looking at the same thing you are?
Yeah, so here, over here, I don't quite so direct dir/file is the same as like to this one, like readme.md.
It's literally the file named dir/file. So on line 38, we created a folder named dir, and then line 39, we're creating a file named file inside that folder dir.
Okay, but this file is the same as this one.
That file is a variable that will be equal to the ABCD.
Oh, okay. Okay.
If you look at some of the other examples, they are like dir/$ file. And in that case, it would substitute the variable there and be dir/A, dir/B, dir/C, dir/D.
Okay. Okay, I see. And also the concept of dev/null, I don't, I'm still a bit confused.
So the main takeaway from it is just that it deletes the output. So by default, git init print something to the screen. Redirect /dev/null just says delete the output. Don't do anything with it.
Okay, but delete the output means that delete all the lines.
The things that would have been printed to the terminal.
Oh, okay. So there's no like line there, or it's just a blank line when we.
Exactly, it doesn't print anything.
Okay, okay, and to this sign is the same as this one.
Well, yeah, so for the purposes of this quiz, you don't have to understand the difference between the greater than and the 2 greater than. It just means that if there's an error message with git init, then the first greater than ignores the error message, or error message still gets passed to the screen and printed. The 2 greater than says, even if there's an error message, don't print the error message.
Okay. Thank you. Yeah.
Hey, Nan.
I guess I was the one that was having a hard time right here. Yeah, I really didn't understand the examples, to be honest.
Okay.
I was just kind of lost because the first time I'm saying it again.
Right.
So I was just like wondering. I don't know if you will advise me to watch the video again and like then come with like specific questions, or you want to go over it right now.
I think if you had specific questions,
Yeah,
would probably be more
yeah.
helpful.
The thing was just like for even for the finger, I had a hard time until like I wanted to ask that question too, and like she came and you kind of answer it how to use the finger because I was using the lines without like putting the thing. I do not know where to separate it and where to not separate it. To be honest,
Right.
like, still new to me. I don't really watch all the video, but I was able to do the homework because like as soon as I learned the material that needs to be done, I just go ahead and do the thing. I like spend most of my time doing more of the GitHub thing and getting him working this weekend. But I don't
Okay.
really like get to that point, so that's why I don't know if that is specific material to speed it up because I feel like I'm a little behind. I'm already feeling the pressure of being behind a little bit, so it made it like harder to understand things today.
Yeah, that makes sense. And I think that's a, I mean, it's a fine place to be at right now. That I know there's a lot of people who haven't seen any of this before. I think I haven't made an announcement about this, but I'm planning on having maybe a more detailed review session sometime. They can go a little bit slower about maybe some more background information. Um, but yeah, I don't know if you do have specific questions. I think that's easier, probably more helpful than a more general
Yeah,
thing.
I just also like I would just ask this for like I will ask this since I already finished this and I can focus on anything else. So as soon as we fork the homework, we have to submit the homework to Sakai, right?
That's correct. You have to both um, submit it to GitHub and to Sakai.
I already like push it to GitHub right now, and it's like they say that it was like one submit in advance than your one. It was like one comment ahead of like your uh thing, and I was just like wondering, do I just take the link and just submit the link to Sakai or?
Exactly.
Okay, so I'm gonna go ahead and do that, and I just feel like I would just like review the last class and um go jot things down and like probably get back to you and like if I have a problem with it because I don't know. I might have a question right now and that question is not gonna be helpful because if I don't understand the core thing, I cannot just make it. So I'll just like go over like the two classes that we just went over, like the last class, the video, and this class to and like see what did I miss and how to like do the things. It might probably be easy. I feel like you went a little bit over like the geography, the Twitter geography thing or something last class when you explain about how to do some stuff with it. So hopefully that with this class will just like help me like understand the quiz that we did.
Okay.
All right. So thank you so much for answering. I will just try to submit the assignment right now. Oh, we have to submit the lab too?
Yeah.
Is it the link or?
For the lab, there's no, it's not a link to GitHub. It's just, there's the 3 questions at the end and you just copy and paste your answer or write it directly into Sakai.
Oh, okay. All right. I'm trying to submit this right now. Continuous integration. All right, I already submitted